Question 5c asks us to find the gradient of a line that is perpendicular to this line here, and it gives us the equation. So we should recall that whenever we have a line which is written as y is equal to mx plus c, meaning some value times by x plus a constant on the end, that this value here, m, is the gradient of this line. So we know that the gradient of this line is 2/3. We should also remember that for perpendicular lines, the gradients of the two lines, if we were to multiply them together, so the gradient of the first line times by the gradient of the second line, that will simply equal -1. So if we want the gradient of the perpendicular line, we know that m1 times by 2/3 is equal to -1. And if we were to rearrange this, we'll know that m1 is equal to -3/2. And how did I get that? It's -1 divided by 2/3. And when we divide by fractions, we flip it upside down and multiply, so that becomes -1 times by 3/2, which gives me -3/2. So the gradient of the line that's perpendicular to this equation will be, the gradient will be -3/2. Question 6a asks us to find the equation of a straight line with gradient 3 passing through these points. We know there's a three-step process to finding the equation of a straight line. Step number 1 says to find the gradient. In this particular question, that's very simple because we've been given the gradient, so we know the gradient is 3. Question 2, the step 2, sorry, is that we need to find c, or we need to find the constant on the end. So knowing that our equation, the standard form of the straight line is y is equal to mx plus c, we have 3 pieces of the puzzle here. We know that m is 3, we know that x is 1, and we know that y is 2. So we can substitute these into the equation. So 2 is equal to 3 times 1 plus c on the end. So 2 is equal to 3 plus c. C must equal to -1. And so step 3 says to write the equation. The equation for this straight line, the straight line with gradient 3 passing through that point, will be y is equal to 3x minus 1. Question 7a asks us to find the equation of the line passing through these 2 points, and we're asked to express our answer in 2 different forms of the equation. So let's find the equation first, and then we'll worry about how to express it. So as per usual, step 1 is to find m, or the gradient. What I'm going to do is I'm just going to draw a little diagram here. So I'm going to, this point here, I'm going to call it 3, 1, and I'm going to draw the other point there, and I'm going to call it 5, 2. It really doesn't matter whether we call these 3, 1 or 5, 2. In fact, let me change them around. The math doesn't change. So I'm going to call this one 5, 2 because it was first, and 3, 1 because it was second. And I like to use the rise over run method, so I'm going to calculate the rise and the run. Well, the rise, or the run here, for example, from 5 to 3 is -2, and the rise is -1. And we can use these 2 values here to work out our gradient. So m is equal to rise over run, and the rise we worked out was -1, and the run was -2, so our gradient is 1/2. Now you could also use the other formula, m is equal to y2 minus y1 over x2 minus x1. That will come up with exactly the same values. Let's call this point 2 and this is point 1. So y2 is 1 minus 2 over 3 minus 5. Again, that gives us -1 over -2, and that is equal to 1/2, which is obviously the same gradient as it should be. So step 2, we need to find c, and we can pick either one of these points. Let me pick the point 5, 2, and we know that y is equal to mx plus c. Well, this is our point x and y, and this is our m here. So we've got 2 is equal to a half times by 5 plus c, and so that gives me 2 is equal to 2.5 plus c. C is equal to minus a half. And so the last step is to write the equation. The equation will be y is equal to a half x minus a half. Now we're also asked to, so this is the form y equals mx plus c. We're also asked to write it in the other form, and so what I'm going to do here is I'm just going to rearrange this. So I've got that, just running out of space here, but I've got that y is equal to a half x minus a half. Let's get both of these over this side, so I've got y minus a half x plus a half equal to 0, and I'm just going to multiply right through by 2, which gives me that 2y minus x plus 1 equal to 0, and that is our second form of the equation. Doesn't matter that I've got y and x here and it says ax plus by. It is basically the same form of the equation. If you wanted to get very technical, you could write it as minus x plus 2y plus 1 equal to 0.